Okay, moving on to a completely different topic now. We're going to be taking a look at vectors. And in your notes, there is a lot of vocabulary and definitions that I'm not going to take the time to read in the video because that would be super boring for me to read what's on the page that you're able to read yourself. But if you have any questions on that, please make sure you email me, or in our Collaborate session, you talk to me about it. So what we're going to, so just FYI, we're 7.6 vectors. So what we are going to take a look at here together in the video is this idea of looking at two different vectors and determining if they are the same or not. So if we have vectors, and in the world of vectors, we don't use X's and Y's. The variables we use to talk about and define vectors are generally U, V, and W. So we go to another part of the alphabet. So we have two vectors here, U and V, and the question is, are they equal? And just a little bit of notation that when we're looking at vectors and it's printed, we have the luxury of writing them in this boldface type here. So this U and this V are boldface. So that tells us that it is indeed a vector. However, we can't write, or I don't have the skill of writing in boldface print. So when I write these, frequently you'll see me write something like this, U, with what looks like a little arrow on top. And that says that that is vector U there, since I can't write in boldface type. So U and V, are these two vectors equal? If we come back here to the top of the notes and take a look, it says that in general, two vectors, in this case V and W, are going to be equal if they have the same magnitude and the same direction. So magnitude and direction are what we want to look at. And what does that mean? Well, magnitude is the length of it. So magnitude kind of represents a quantity. So the magnitude of U is going to be the length of this U, and the magnitude of V is going to be the length of V. So we're going to look at the magnitude, or the length of the vector. And then in terms of direction, the direction is, so where the magnitude is how long is it, the direction is what, well, kind of as it says, where is this pointing to? How does this look? What direction is it going in? And that is going to be defined by our slope. So to find if U is equal to V, we're going to have to look at two pieces of information. The magnitude, which is going to be the distance between the 2 points, and then the direction, which is the slope. So in terms of our magnitude, looking at magnitude, and this is going to be the distance or the length. So it's either the distance between our beginning point and our end point, the distance between our beginning point and our end point. And notice, oh, by the way, a vector always has an initial point, a beginning point, and an ending point. And the direction is very important. In this case, we're moving from this point of -5, 2, going up and to the right to get to the ending point -2, 6. So that would be the direction. So magnitude is the distance between this point and this point, and for this vector, this point and this point, or another way to think of it is the length. And so the notation we use for this is this thing that looks like almost two absolute value brackets. So first I'm going to look at vector V, and the length of this is the distance. So we haul out our old distance formula, which says that it's x2 minus x1, or the distance between the two x values, squared, plus y2 minus y1, or the distance between the two y values squared. So there's our distance formula. I'm using it for U, but it's the same distance formula that we're going to use for every vector. So now let's take a look at u. Here, my point here is -5, 2, and here it's -2, 6. So I'm going to call this my x2. So this, if we label this x2, y2, and this is x1, y1, just so that we know where we're pulling these points from. So this is going to be -2 minus, now this x is -5, so we have a whole bunch of negative signs here. The subtraction from the formula, and then the negative because that x is -5. And this is squared, and now moving over to our y's, we have 6 minus 2. 6 minus 2, looking at our y values, and this is squared. So now here we have negative, negative, that makes +5, -2, and +5, 3 squared. And then over here, 6 minus 2 is 4. So we have 4 squared. And now we have 3 squared, 9, 4 squared, 16. 9 plus 16 is 25. Whoops. And now this would be 5. So the magnitude of vector u is equal to 5. Now we're going to do the same thing for, man, I am just right off of that paper, aren't I? We're going to do the same thing now for vector v. So here the magnitude of vector v. So I should have switched to different colors. So here, this is going to be again our x1, y1, and here x2, y2. And let me switch this to green so we know this is a different vector now. So here we have 5 minus 2, 5 minus 2, 5 minus 2 for our x's squared, and now we have 6 minus 2 for our y, 6 minus 2 squared. And this is 5 minus 2, we have 3 squared, 6 minus 2 plus 4 squared. So this, we can see it's the same as there, going to be square root 25, which is 5. So the magnitude of u is 5, and the magnitude of v is 5. So the magnitudes are the same. So it satisfies that requirement. Now we have to consider direction. So as I said before, the direction of a vector is going to be, what we're going to use for that is the slope. And the formula for slope is, so m is equal to y2 minus y1, x2 minus x1. Same slope formula as before. So since red is the color for our vector u, for our vector u, it's going to be equal to y2 minus y1. So we have 6 minus 2 in the numerator, and then x2 minus x1. We have -2 minus 5 in the denominator. So 6 minus 2, we have 4 in the numerator, negative, negative. This is positive, -2 plus 5 is 3. So our slope for our vector u is 4/3. And now we have to go through the same process for v. And since v has been defined as green, we will look at v. So for vector v, same formula. So we don't change the formulas for each vector. It's just rinse and repeat the information. So for vector v, we have 6 minus 2 in the numerator for the change in y. And the denominator, we have 5 minus 2 for the change in x. So we have 4 over 3. So our slopes are the same. And our magnitudes are the same. So because both the magnitude and the direction of these vectors are the same, these vectors, the conclusion, this means conclusion in math, 3 little dots there, the conclusion would be that vector u is indeed equal to vector v. If we had the same magnitudes, but say instead of 4/3 and 4/3, say this was -4/3, these directions would not be the same, and so these would not be equal. Both conditions have to be satisfied.